Hello. Hello and welcome to this read through of PostgreSQL documentation. We are in chapter 9, functions and operators. And inside chapter 9, we are doing with the JSON functions and operators. So if you have not watched previous video, I suggest that you watch previous video because what we are going to discuss will involve knowledge from this previous video. So this is what you should look at. We take this piece of JSON and we store it in the variable named JSON. Okay, and the queries will depend on that. We had covered all this. So we are going to resume at strict and lax mode. Also at the end, I will show you my question answer website where you can come and ask SQL based questions, and I'll be happy to answer that. So we resume the read through without delay. And one more thing is that at the end of all this theoretical read through, I'll give you one comprehensive example of everything which we have studied. So without further ado, let's get started. When you query JSON data, the path expression may not match the actual JSON data structure. An attempt to access a non-existent member of an object or element of an array is defined as a structural error. SQL or JSON path expressions have two modes of handling structural errors. Lax, which is the default. The path engine implicitly adapts the query data to the specified path. Any structural errors that cannot be fixed as described below are suppressed, producing no match. Strict, if a structural error occurs, an error is raised. Let me check if sound is getting recorded. Yep. Okay. Lax mode facilitates matching of a JSON document and path expression when the JSON data does not conform to the expected schema. If an operand does not match the requirements of a particular operation, it can be automatically wrapped as an SQL JSON array or unwrapped by converting its elements into an SQL or JSON sequence before performing the operation. Also, comparison operators automatically unwrap their operands in lax mode, so you can compare SQL or JSON arrays out of the box. An array of size 1 is considered equal to its sole element. Automatic unwrapping is not performed well. The path expression contains type or size methods that return the type and the number of elements in the array respectively. Excuse me. The queried JSON data type contain nested arrays. In this case, only the outermost array is unwrapped, while the inner arrays remain unchanged. Thus, implicit unwrapping can only go one level down within each path evaluation step. For example, when querying the GPS data listed above, we can abstract from the fact that it stores an array of segments when using lax mode. So in the lax mode, we query $.track.segments.location and we get, excuse me, so we get these locations. In strict mode, the specified path must exactly match the structure of the, sorry, give me a moment, let me drink some water. Okay. So in strict mode, the specified path must exactly match the structure of the queried JSON document. So using the path expression will cause an error. So if we use this path, then it will say that JSON path member accessor can only be applied to an object. To get the same result as in lax mode, you have to explicitly unwrap the segments array. Seems like a mosquito has flown into my mouth. So we have select JSONB path query and we query over the JSON field strict mode $.track.segments star. We access each element separately and find the location. The unwrapping behavior of lax mode can lead to surprising results. For instance, the following query using the .** accessors selects every HR value twice. So here we are looking at the root node, and then we are looking at fact segment, and then HR. So it will select it twice. This happens because the dot star star accessor selects both the segment array and each of the elements, while the dot HR accessor automatically unwraps arrays when using lax mode. To avoid surprising results, we recommend using the dot star star accessor only in strict mode. The following query selects each HR value just once. So in the strict mode, the same query will access HR once. The unwrapping of arrays can also lead to unexpected results. Consider this example where which selects all the location arrays. So in the lax mode, we select the location of all the segments, and we have that. As expected, it returns the full arrays, but applying a filter expression causes the arrays to be unwrapped to evaluate each item, returning only the items that match the expression. So here we select the array elements which are greater than 15, so we get only 47 outside the array. This despite the fact that the full arrays are selected by the path expression. Use strict mode to restore selecting the arrays. So in the strict mode, we get the entire array in this case. Now we will go through JSON and SQL and JSON path operators and methods. Table 9.52 shows the operators and methods available in JSON path. Note that while the unary operators and methods can be applied to multiple values resulting from a preceding path step, the binary operators can only be applied to single values. In lax mode, methods applied to an array will be executed for each value in the array. The exceptions are dot type and dot size, which apply to the array itself. So first we have number plus number. So we do JSON path query, and our array is 2. Then we select the root element of 2 here, of this array, 0th element of this array, the root node's first element, and add 3 to that. So we get 5. Then we have unary number plus, and this is our object. And to each number of this root node, and then we select key x. That is each element to this, we apply the unary array. You read the description, unary plus, unlike addition, this can iterate over multiple values. Then we have subtraction, like addition, we have 7 minus 2, that is 5. Then we have unary negation, unlike subtraction, this can iterate over multiple values. So if we supply minus before $.x, you get minus 2, minus 3, minus 4. Then we have number multiplied with number, that is multiplication. In this case, it will be 2 times 8. Sorry, 2 times 4, which will be 8. Then we have division, 8.5 will be divided by 2, that is 4.25. Then we have remainder, 32 remainder 10, 32% 10 will give you 2. Then we have dot type of the JSON item. So we have this JSON value here, and we iterate over each element and find out type. So first one is number, this is a string, and this is an object. Then dot size of the JSON item. So we'll look at dollar, that is root node, and then M key, and then we find the size of this key value of this key M. So this will be 2 because there are 2 elements in the array. So size of the JSON item, number of arrays element, or 1 if not an array. So if it is not an array, it will be 1. Then we have value dot boolean. So boolean value converted from a JSON boolean, number or string. So we have an array 1, yes or false, and we iterate over each element, and we apply boolean function on those. So 1 will be true, yes will be true, but false will be false. So you need to know JSON notation or JavaScript, what is true and false in JavaScript, and then you can figure out this easily. Then we have value.string, string value converted from a JSON boolean number, string, or date time. So we have this array 1.23 XYZ and false, and all those were converted to strings by using this transformation. And then we have date time, which is converted to string, so it is within double quotes. Then we have value.double, approximate floating point number converted from JSON or string. So then here is 1.9, we select the root node, then we len, and then we invoke double on that. So we get the floating point number 1.9 and we multiply it with 2. So we get 3.8. Note that it is a string. Okay. But the double on this string will convert this into floating point number. Then we have ceiling nearest integer greater than or equal to the given number. So nearest integer of 1.3 is 2. We have floor nearest integer less than or equal to the given number 1.7. Nearest integer less than that is or equal to an integer will be 1. Then we have solid value minus 0.3 becomes 0.3. We have big integer value converted from JSON number or string. So we have this big int and we convert it to big int, so it becomes an integer. Note that I say it is a string here. Then we have decimal with optionally precision and scale. Rounded decimal value converted from a JSON number of string. Precision and scale must be integer value. So precision here is 6 and scale here is 2. So we get 1234.57. Then we have value dot integer value converted from JSON number of string. So here we get 12,345. Excuse me. Then we have value dot number, numeric value converted from a JSON number of string. Similar behavior. Date time will convert value from string to date time. Okay. So now we have date time, which takes a template. Date or time value converted from a string using the specified to timestamp template. So our template here is, this is the input to date time values 1230 and 1840, and we want to convert it to HH in 24-hour format and minutes. So that's what we have here. Then we have date value converted from a string. So we have a string and we convert it to a date. Then we have time, you have a time and you convert it to time. Similarly, time with precision is here. So precision is 2. So 789 is rounded to 79. So TJ will give us time zone value converted from a string. So time zone here is 530. So time with time zone will be given here. String dot time period with precision. So if you give a precision here, the millisecond will be wrapped into those many fractional digits. Then we have timestamp without time zone value converted from a string. So this is a string and we have timestamp without time zone. Then we have timestamp with precision, just like other ones. We can wrap the milliseconds into certain digits. Excuse me. Give me a moment. Then we have timestamp underscore period, which is timestamp to which time zone value converted from string. So we have a timestamp with time zone and we convert it to string. Then we have the same function with precision, so it is there. And then we have object.key value returns an array. The object's key value pairs represented as an array of objects containing 3 fields: key, value, and ID. ID is a unique identifier of the object the key value pair belongs to. So here our object is 20 and 32 with the values, keys are X and Y. So we convert it to key value, we get an ID 0, key X value 20, then again ID 0, key Y and value 32. Then we have a note here, it's quite big. So let's go through it. I don't think I should continue this. I have got problem in my throat with that mosquito. So we will continue from here tomorrow, and I will wrap this video here now. Let me show you my question answer website where you can come and ask questions, SQL questions. The website is kunjika.ashtavakra.org, and you can create a login here and tag your PostgreSQL questions under SQL tag, and I'll be more than happy to answer your questions. So with this, I would like to end this video here, and we will meet again tomorrow, resuming at this note. My most sincere apologies for that mosquito issue. It severely gave me problem in reading all this. So thanks a lot for watching the video. We'll meet again tomorrow with more on SQL and JSON topic of functions and operators of PostgreSQL. So thanks a lot for watching the video. I'll see you tomorrow again in one more video. Till then, have a nice day. Stay curious, keep learning, and most importantly, enjoy.